Good evening everyone. Welcome to RJ Skill the Versatile World. Today we are going to learn about aldol condensation. Okay, so let's start about aldol condensation. Aldol, it came from suffix of two functional group, that is aldehyde and alcohol. Aldehyde, I am talking about aldehyde. Aldehyde, suffix of aldehyde al and OH, alcohol, suffix of alcohol all, and it form aldol. Okay, here we can say aldehyde having alpha H is treated with base like NaOH, KOH. Okay, it form beta hydroxy aldehyde and later it loses water molecule and form alpha beta unsaturated aldehyde. Okay, we can say here also about carbonyl group, aldehyde and as well as ketone. Okay, aldehyde and also ketone having alpha H. Okay, but here I am taking aldehyde. Okay, aldehyde having alpha H is treated with base like NaOH, okay, like NaOH, KOH, it form beta hydroxy aldehyde and later it loses water molecule, it forms alpha beta unsaturated aldehyde. Okay, so aldehyde having alpha H is treated with base like NaOH, KOH, it form beta hydroxy aldehyde and later it loses water molecule and it form alpha beta unsaturated aldehyde. It is known as aldol condensation. Okay, so aldol condensation, types of aldol condensation, self aldol condensation in which same molecule, okay, same molecule of aldehyde will react together and form alpha beta unsaturated aldehyde. And also another type which is cross aldol or simply known as mixed aldol, in which another molecule, okay, maybe one acetaldehyde and second one is propanol, okay, react together, and also we can say one aldehyde and another will be ketone. Okay, cross aldol. And another types of aldol condensation is intramolecular aldol condensation. You know about intramolecular, within the molecule. Okay, and they are form cyclic ring. But in this video I'll talk about self aldol condensation. So let's start. Self aldol condensation. Okay, in this reaction self, it means I am taking here acetaldehyde CH3O C double bond OH, okay, in the presence of base, okay, it form CH3 COH H CH2 C double bond OH, alpha beta hydroxy aldehyde, and later it loses water molecule by E1CB reaction. Okay, I'll explain with the help of mechanism, so don't worry about it. Okay, so here it loses water molecule and forms CH3 C double bond H and C double bond OH, alpha beta unsaturated aldehyde, alpha beta unsaturated aldehyde. Okay. Now with the help of mechanism we will know about self-aldol condensation. Okay. So mechanism is very much important in organic chemistry. Okay. So I'm talking about mechanism. CH3 C double bond OH, here taking a base, you know about base. Okay, here base, and these functional group have alpha carbon, and this alpha carbon having alpha hydrogen. Okay, alpha carbon get attached to this hydrogen, and this hydrogen is known as alpha hydrogen. I am talking about alpha hydrogen is treated with base. Okay, like NaOH. NaOH gives OH. Okay, and OH will abstract. I can write like this: CH2H. Okay, CH2H, CH3. Okay, so OH will abstract H plus, because OH minus and here H plus. H2O will remove. Here reaction, acid base reaction carried out. Okay, acid base reaction, you know about acid and base. Okay, according to Arrhenius, base which gives OH minus when dissociate in water, and acid which gives H plus when dissociate in water. Okay, according to Lewis, electron donor is a base. Okay, electron pair is donor, base, and electron acceptor is a acid. So here taking acid base reaction, OH minus abstract, okay, H plus. So here develop negative charge, CH2 negative C double bond OH, here form nucleophile. And you know about nucleophile, which is nucleus lover. Okay, which is nucleus lover. Nucleus lover, I am talking about nucleus lover. Okay, so nucleus, it means positive part. Okay, and positive part is the electron deficient. Okay, so this is a nucleophile which attack over positive part. So we take another molecule of acetaldehyde. Next step, another molecules of acetaldehyde, because I am talking about self-aldol condensation. Okay, it is a very, very important. Okay, now we will talk about, we are taking another molecule, CH3 C double bond OH, and nucleophile CH2 C double bond OH. Okay, here now listen to me carefully. Okay, due to this reagent, nucleophile, due to nucleophile, in the presence of nucleophiles, and due to more electronegativity of oxygen, it attracts electron toward itself, and here develop negative charge, and on over carbon develop positive charge. Okay, so negative part will attack over positive part and form CH3CO negative H and CH2 C double bond OH. Carefully, CH2 get attached to this carbon. Okay, CH2 get attached to this carbon, and this hydrogen is get attached to this carbon. Okay, so CH2 get attached to this carbon and form this. Okay, And here also we can say nucleophilic addition reaction will take place. Okay, nucleophile get attached. Okay, so nucleophilic addition reaction. Okay, and nucleophilic addition reaction is more easily in aldehyde. So reaction is faster, nucleophilic addition reaction is faster in aldehyde than ketone, because here develop more positive charge and ketone having less positive charge. Due to this COCH3, okay, it attracts electron towards itself, negative and positive, but due to inductive effect, plus I effect, okay, plus I effect, it develop less positive charge. So nucleophile do not get attached easily. Okay, and here more positive charge, so nucleophile get attached easily. Okay, now H plus OH minus. Okay, H plus get attached to this O negative and form CH3 CH OH CH2 C double bond OH. Okay, alpha beta, here beta hydroxy aldehyde. Okay, beta hydroxy aldehyde. Now E1 by E1CB reaction. Okay, it loses water molecule and form alpha beta unsaturated aldehyde. E1CB reaction, elimination unimolecular via conjugate base. Okay, conjugate base, it form alpha beta unsaturated aldehyde. So let's start E1CB. Okay, OH minus, which is base. Okay, now listen to me. We can write one more step for easy to understand. Okay, CH3 CH OH CH, I can write like this, H CH2. Okay, and C double bond OH. Okay, this OH, okay, or you can say easily, here H plus is transferred and OH minus is remaining part. So OH minus will accept acidic hydrogen. Okay, so it take, okay, OH minus will take H plus and here negative charge transferred. Okay, so now CH3 CH double bond OH and CH minus C double bond OH. Okay, E1CB reaction occurs in two steps. Okay, at first step, conjugate base abstract acidic hydrogen. Okay, and in another step, poor leaving group goes out. Okay, so now this electron shifted here and formed bond, and it will take electron and goes out from here and form CH3 CH double bond CH2 and CHO, alpha beta unsaturated aldehyde. Okay, this reaction is known as Aldol condensation. And thank you so much for being with RJ Skill, the versatile world.